Yeah, I'll just cut the template out. This is the old schematic though. This is not the new one, but just to get the board layout size. And I've been cutting a piece of copper board to the right size so that it's actually. I've made a bit extra board though because I've left a bit of extra board there, but I've left a track down on it. I've cut partially through it so you can see the light through. I did that because I've got another little board I want to make as well, but it's not even worth doing a video about. It's just some diodes and rectifiers and things to do, you know, to do with the different projects. So I'll probably talk about that sometime. It's to do with the pulse motor. So I thought, well, while I'm at it, if I'm going to be doing the transfer part at some point, I might as well add that bit on and do it all at once. Because actually trying to iron a tiny piece of board, a small board, is actually harder than doing a larger board, because the iron tends to rock about side to side on a small piece of board and it's not as even. So by doing it all at once, I haven't actually done the template for that yet, but by doing it all at once, it makes it easier, you know. So yeah, I had a heck of a job trying to cut this, I tell you, because my hacksaw has seen better days. It's got a few teeth missing, and yeah, as you can see, it's got a few teeth missing there, and keeps getting jammed. It's really hard work. It's very difficult cutting anything that's hard. It's not so bad with wood, but yeah. Okay.
Right, well, I made some other changes actually. I added a 1.2 mega ohm resistor actually across C5 because yeah, I noticed that in some situations it wasn't triggering, and I'm hoping that will improve it a bit, because it's basically on the feedback loop from the output of the IC and to I can't see it actually, pin 3 as in the non-inverting input. So it just makes a slight it helps the circuit toggle on basically when there's enough of a change. And well, luckily on the PCB layout I had room for it, and it's R12, it's this one here, so I can't click on the damn thing. R12, so I just had to move R3 over to the right a little bit and move C5 over to the left a little bit, because it's actually wired in parallel with C5. So sorted that out. The design's coming on quite well, and this is the other board that I wasn't going to really talk about, but I might as well, because it's to do with the pulse motor circuit. It's a different circuit I'm working on. Basically, I've got a whole bunch of coils on the pulse motor, and I need to rectify the voltages from all the coils. And so it's simply a bridge rectifier. There's a bunch of bridge rectifiers, and I'm going to be using they're actually Schottky rectifiers, so there's minimal voltage drop. And I've got a whole bunch of these Schottky bridge rectifiers. There's about let's see how many I forgot how many I put in now. 1, 2, 3, 4, 5, 6. There's about 6 there. So yeah, because there's actually, if you was to, I haven't actually discussed about my pulse motor yet, but basically my pulse motor has 6 coils, there's 6 magnets, and some of the coils are going to be wired in series, but I've got actually a bunch of other coils which actually on different platters. So I want to be able to feed each set into a different bridge rectifier circuit, and then they're rectified to DC, and then the DCs are all paralleled up. This is why at this end the DCs are all paralleled up. That's why, and the only reason that track is a different colour is because I chose to highlight that particular track. If I right click on this track, I can let me see. My eyes are really bad. Oh. Right, I can't seem to see right now. Can't find it in the menu. I'm just looking, and there's a thing for highlighting that circuit. I'll have to go through the menu. Hang on. Highlight net. That's it. Selected nets. Right, now I've switched it over. There we go. I'm highlighting the other net now, and it enables you to make sure that there's no breaks in the circuit, and it just makes them very prominent. So if you've got a break in the net, for example, as in the circuit's not connected properly, you can usually pick up breaks that way. And as I say, this board's tagged on to the other board, so when I've etched it, I can cut the board right down the middle and cut it in half. I just showed you a video just before this where I cut the board partially down the middle, and that's where this one's going to be, on the little end. And if you look at the 3D, the 3D is not a really good representation, but the components on the 3D tend to be a little bit too big. It looks really big, but it's not really. So this is the new improved design, and that resistor I just added. One I just added is R12. It's just over here, just next to the capacitor here, C5. So that's the one I just put in. It's a bit of a tight fit, but it's going to fit all right anyway. And going back to the other board, which is a tag on, and actually the bridge rectifier is a surface mount. So just zoom out a minute. The bridge rectifiers on here are actually surface mounts, so they're actually they're represented by those big red blocks there, but they're actually tiny little things. So I mean, these 3D representations are really not very good, but you can see the surface mount pads underneath them there. Oh god! If I just get it in the right position, I can't really do it. But anyway, the pads are right underneath my mouse here, where they sold one to, and then there's some other. The other pads are just underneath there where it's soldered on, but the other components, the terminals on the other side, are actually on the other side. So that's the reason why I've got components on that side, whereas we normally don't. It's because the surface mount. I hate surface mount, to be honest. They're so tiny, but I figured that because they're just four-legged devices, I should be able to manage to solder them on. If I have problems, I could use conductive paint anyway or something. But anyway, whatever. So yeah. Anyway, anyway, that's pretty much it. But I think I'll try and show a video. I've done some videos previously on the pulse motor circuit briefly, but not really much detail on it. It's all extremely experimental, and there's a lot of people on the internet doing these pulse motors. I thought it was something interesting to play around with. It's you know, a lot of people claim that you can get free energy from them. Well, I don't know if you can or not, but well, we can certainly try. Oh, and my circuit just tripped in over there. I've been doing a test since I added R12, and it seems to be, yeah, it seems to be made the circuit even more stable. So R12 is definitely working a bit better. Certainly appears to be made some improvement there. So I'm glad I was able to put that in before I actually did the board and etch it and everything, because it would have been a hack job if I'd had to add it later. So that seems to help. Anyway, enough of that. Thank you for watching.
Right, on a side note, these are what other people have been calling Starship coils. I've been winding these on a very small scale, and these are very small. I'll put some terminal contacts on there. Let's pick a better one up that's easy to see. You can see I've got quite a few I've made. Terminal contacts, I've used copper tape on the sides where I can put my wires on. And basically, let's get the light on it. Let's see, there we go. You can see the copper windings inside. This is for a project, a side project, just for the fun, really. I've embedded them in resin, I think fiberglass resin. And so far, I've made about, let's see, set the magnifying glass away, because it helps with focusing that small thing, but 1, 2, 3, 4, 5, 6, 7, 8. I've got about 8 here. I've got actually 9, but the other one's in the bedroom. There's no point picking them all in. But yeah, this one's, I've attached some wire on this one. And these are experimental coils I made. They're all different colours, and this one's got like a pinkish colour on it. But some of them are kind of orangey. I did try using coloured dye with them, you know, actually some ink, printer ink. And they're about the size of a 2p piece. Now if I get this 2p piece, UK money, and put it on top, you can see it's about the same size in diameter as a 2p piece, and they're very small. And I used a little jig which I made. Oh, here we go. Let's get this jig here. I made this little jig, and it's got loads of nails in it, and with some plastic waxed on one side, and using like a top clamp, which has got a foam rubber stuck to it, like a rubber sheet. And basically, I wind the coils. I put little cotton bud shafts around on these nails, so it makes it easy to remove the coil once it's been wound and set in, and once it's set in resin. And I put this thing on top here. Then I put elastic band around to clamp it onto this drum, this plastic container. It holds it down tight. And then once I pour the resin inside here, once it's hardened, then I remove the spool, and then I have to prise up this plastic sheet underneath, which lifts the cotton bud and the resin, which you can see the coils have got little white cotton buds shafts inside there. Lift the whole lot up and off the pegs, and there's my coil. So I've got some air bubbles in, but doesn't really matter about those. And then I have to, because they don't come out perfectly flat and even, so what I have to do then is I have to set them on the table, like on here. Then I have to put resin over the top, dab it on lightly, and then I put a piece of plastic over the top to make it dead perfectly flat. So and then when it hardens, I've got a nice smooth surface. I've had to do that actually on all of them, and it's a long job. I was doing about 1 coil a day because they were fiddly, because of the wires being so thin, and I had a few mishaps where the wires broke off, and I had a hell of a job trying to repair them, or you know. So, but anyway, and this is for my experimental motor project which I'm building. I've shown some short videos on YouTube, but not really explanation. And there's some other coils I made on bobbins, but there's no resin Starship coils in there yet. And I had some coil formers wound, made for me, which are like a triangular shape. And I wound the coils on there. Let's just pause a minute. Right, here we go. I had some of these made, 3D printed for me. They're actually very special formers. If you look at the former, getting the magnifying glass again, make it a bit easier to focus. Right, they're actually stepped. So when I wind the coils, because as the magnetic field goes outwards, as it goes further out, it spreads out, as you know, with a magnetic field. So I decided to optimize that by having the coils spread out further, so I don't use as much copper on the further distance from the magnet, and the coils are more concentrated in the center, nearest to where the magnets are, and there's a hole going all the way through. I didn't realize it, but when I was having these made, somebody else had actually invented them. But mind you, I don't know if they use what I do. I don't know if they've actually stepped like this actually on the former, but I know that they're stepping the coil windings. I don't know if it's the same thing. And anyway, I also had these. I had some bobbin type plastic discs made up, and I had to glue these together with super glue because they're actually made out of 4 parts. There's 2 large discs. There's 2 large discs on each end, and there's 2 smaller discs glued together in the middle to make my coil formers. That's the ones that I'm using in here. And these ones here are the ones which are actually being used in here. And there's no drive circuit on this motor yet. So what I've done is just hook up to a simple drive belt for now to a motor, because I haven't actually got a pulse circuit built for this yet. That's another job I've got to do. So anyway, I can actually spin it up using this motor, and it takes a while to get to speed. Turn the power on. It's current limited, so let's give it a little help. And just run it off this tiny 6-volt motor. And there's a bit of strobing effect going on here. So I actually had to have all the plastic parts cut on the laser printer by somebody on eBay. And I got the bearings. And I had the drive shaft lased for me by a local engineering firm, because I got one off eBay, but it was bent and it was no good. So there's a bit of wobble on my discs, but it's not a big problem. And I got some hard drive platters on one end, so it acts as a bit of a centrifugal counterweight. And it's getting up to speed, but I don't know how many RPMs it is. I could work that out using frequency counter, and it's probably getting quite loud now. It does get kind of loud as it gets to speed. But yeah, I'm not really generating any power yet, but it's not really connected up to anything. So I just thought I'd show that. Oh yeah, I had these made. I had these made so I could have 60 stators, which are these. Stators are 6 rigid. I'll just turn it off. It's kind of loud actually. So it's not really doing any generation or anything, but it's an experiment. Other people have been making them, and I thought, well, maybe it's something I can do on a rainy day, just something to tinker around with. these clips actually, I'll just pause. Alright, these clips, I had to get these 3D printed on eBay. Some guy on eBay was doing 3D printing jobs, and I thought, well, I'll get these made up. I had some holes made in them so I could use screws, bolts if I wanted to. But it turned out that just super gluing them to the stators was good enough. They actually stuck really well. But it's easy enough to prise them off if I need to do. But the way I did it was, all these clips are facing the same way, so that I can literally just push them off. Push two of them off, and it unclips, and then I just pull the drive shaft out, and I can remove all the platters and all the stators quite easily for adding coils and stuff like that. It's a bit of a fiddly job because I've got to slide each platter off move it each one a bit at a time, because there's a lot of friction with them all, so I tend to slide one, then another one, and then another one, and I'll pull the shaft out a little bit until I get the whole thing out to bits, but it's fairly easy really. But anyway, as I say, it's an interesting project to be playing around with, but I'm not getting my hopes up. Lots of people are trying to work on means of generating power and everything, but I've just got some ideas I wanted to play with. Just about using leverage and gearing, and driving the outside, and using the center magnets as the pulse generator, because they're neodymiums on the inside and they're just ceramic type magnets on the outside. So, well, anyway, nothing really all that interesting, but still, it's still fascinating. I mean, I've never actually dabbled in all the years of electronics. I've never ever dabbled with starship coils, and it's just something that took to my fancy, and I thought, well, let's have a go. Let's see what kind of effects you can get from them, and they're only tiny, these. By having a lot of them and wiring them up to my rectifiers, which I've just shown you earlier, the bridge rectifiers, which is on that small board, we could either have them in the voltage in series or in parallel or whatever, and see what kind of power we can get out of them, and see if we actually do generate any useful power. It's worth playing with, and you don't learn anything if you don't try, do you? But there's a lot of people who are being accused of being fakers and all this. Well, I'm not even going to go down that road. If I was to get positive results, personally, I probably wouldn't even put it on YouTube, because there's people out there who would claim, oh, it's a fake and all this. So you can't win. If you win and succeed, you're accused of being a faker or a fraudster, and if you fail, then they laugh and say, I told you so. So you can't win no matter what you do. But as I said, this is just a hobby, just something to play around and tinker with, and because I've designed this unit so that I can have multiple sections. I could have standard coils in one section, I could have my pyramid coils in this section, and the empty section over here, well, there's nothing in here right now except this drive shaft. I'll have my starship coils on this section, and then I'll be able to switch between each section into the rectifiers and compare them anyway, and just see which ones behave the best. That's basically it. And all this material is very light. It's all plastic. I use plastic threading, so there's no magnetic pull. It's plastic studding with plastic bolts and nuts and plastic partitioning. There's not, the only thing that's metal really on here is the magnets and the drive shaft and the bearings. That's a bit, and this pulley thing, which is aluminium. So there's not really much metal on there to drag it down or cause a lens effect. So yeah. Anyway, that's it. Thank you for watching.